Hi everybody. In this video we are going to talk about leveraging SQL strengths in order to improve performance in applications in general and specifically in applications that were migrated from pervasive to SQL. So in our current scenario we have a migrated application that used to run on pervasive and it has this interesting data model. We have orders and every order has order details, and in the order details we have products. Now one of the screens in the applications is showing orders per product. Let's have a look at how it works. I have a list of orders that I can go through. I can select a product, and when I select a product, it will only show me orders for that product. In this case, only orders that have product number 5, or number 1, or 2, or 15, any one of those that I want to see. Now, as you can see, it runs fairly fast because we don't have too many orders. But if you would have a lot of orders, this code would work poorly because it's using a relation to determine that. So let's first of all explain how does the existing code works, and then we'll talk about how to improve. So the existing code has two controllers. We can see here that we have the parent controller, the show orders for product, which represents the top side of the screen, where my user can select the product names that they want to look at, and then it has an inner controller that shows the actual orders. Okay, and the inner controller looks like this. Cool. Now in the inner controller, the developer has done something interesting. The from is the orders table, and then there's a relation to the order details table, looking for an order with the same order ID and with the product ID that was selected in the parent controller. Then it says whether or not the relation was successful in a variable called found order detail row, and then it says if the product ID in the parent controller is different than 0, then make sure that the founded order detail row is equal to true, meaning only show rows for which this relation was successful for. Okay, so that's the original developer's intent. Now, this is problematic in any code, but it is much more problematic when you start talking about a move from pervasive to SQL. These kind of many small queries are very expensive to perform in SQL. Let's show you what is actually going on here behind the scenes. Well, I'm going to run the profiler and run this program. So at first glance, everything was okay. Let's look at the result. We can see that the onStart was called. It called the orders inner controller. The orders made a select statement to the orders table, and then 13 select statements to the order details table to look for these orders, which is so far so good. But what happens when we change the value here to 5 or 15? Let's say, again, start the profiler, type 15, and go into the inner table. In this case, we're going to see something completely different. The order details controller was called once, but the relation to the order details table happened 833 times. Okay? 833 times. Pretty much for every order in the data view, it was looking for an order that matches the product ID that I've set over here. Okay, so we've got here 833 calls, and if we would have 10,000 queries, we would have 10,000 orders, we will have 10,000 queries over here. This is where it becomes expensive and inefficient. Now it had to go through the entire database because there were no 20 rows that match. For example, if we do the same with product ID 1, you see that it only went through 232 orders because after 232 orders, it found enough orders to fill the screen. And as I'll page down, it'll go through the rest. So as you can imagine, this is very expensive in performance, specifically when you start going to more complex data views with more complex, many more relations, and using SQL servers, again, this kind of queries is not its strong suit. What we are trying to do is to leverage SQL powers in our benefit. And to do that, there's actually an interesting little helper method in the UserDB methods class called isInSelect. Let's see what it does. We want to get all the orders for which a row exists in the order details table with the products that we're looking for. Okay, so pretty much if you're going to look at the tables themselves, we want to look at the order details table, filter on some product, and then get all the orders IDs that match that product, and only show these orders. Well, for that, SQL has a syntax called inSelect that we're going to use. Let's do that. So this is the original rows that actually filters. It's specifically marked as non-DB-aware, so we'll be aware of its performance deficiency. And we're going to add another row of our own that will replace its functionality. Where add? First thing we're going to use is again CMD range, just like before, because the same condition applies. We only want to filter if a specific product was mentioned. Okay, so this is the basics of our code. Next, we only want to show rows for which a value exists, a product exists in the order detail. So we're going to do this. db.isInSelect, and we're going to choose the column from our table, in this case order ID. We're going to choose the other column to connect to, which is in order details, order ID. And we're going to define the filter, which is order details product ID is equal to parent.product ID. Cool. So what did we say here? We want to have an inSelect that connects via order ID in our table to order ID in the other table. And the other table should be filtered only for order details where product ID is equal to prod ID. Let's run it and see what we get. So in terms of functionality, it works the same. When we didn't set anything, we got all the rows. When we're going to set 15, we're going to get only 6 rows. And you may notice it already runs a bit faster. Now let's go and have a look at what happens in the profile. So first, when we open it, it looks exactly the same. So the call to orders, the original select statement is simple, selecting the orders, and 13 calls to the order details. Okay. Great. Now let's do the same, but now let's define product ID 5. Okay. Let's look at the profile. Previously, you've seen here 832 calls. But now we only see 13 calls because the original select statement now looks a bit more interesting. Okay, you can see here that the call to the db_in_select generated this where statement saying where order ID is in select order ID from order detail where product ID is equal to 5. So by doing this, we're actually able to not only load the rows that we care about and get a lot of performance by that, but actually remove that relation. So let's go ahead and remove the relation because we don't need it anymore. We only need it for this purpose. So we can delete the relation, we can delete the non-DB-aware, and we also need to delete it from the column collection because we're not using it. And this one as well. Let's run it. And here we go. We got much better performance and much more efficient interaction with the database and with very few lines of code. Now, if you want to dive deeper, I recommend that you go to the code of db_in_select and see how we've created it and create your own. There is inSelect, there is not inSelect, and many other examples. I strongly encourage you to improve on this and create any version of this that may suit your needs. And use these kind of techniques, wrap complicated things in simple method, so it's going to be easy to use and take forward. I hope you enjoyed this video. We're going to try to make more, and if you have other performance issues that you run into, please let us know, and we'll try to create examples for them as well. One last sentence here, and a lot of times people try to solve this problem using joins. And I strongly recommend against using joins in a UI controller because most of the time in UI controller you're only looking at part of the data view and not your entire data view. You're looking at the top 100 rows of a million rows database. And when you start using joins there, it will bite you in terms of performance because the database will do the join for the entire database. That's it. Thanks for tuning in and let us know what you think.